Graphing piecewise defined functions. This would mean that we have one or more functions with some sort of parameters put on it. Like, for example, you can see here we have 4x minus 6. We have a bracket saying that we have more than one function, 4x minus 6 and negative 5x plus 10. That f of x we could always substitute as y equals. So if we wanted to, we could rewrite them like this. And those ones are substituted in there because we're talking about an x value that is less than 1. So we're going to go ahead and start at 1. And then everything less than that will be a valid x value. We're also going to take a look at the second parameter, which is x is greater than or equal to 1. And we'll take that as 1 and everything greater than that. So what this does is it gives us the open circle, closed circle. And that's where we're going to be starting, is an x value of 1. So you can see that's where 1 was substituted in for both of the functions. And then what we did is solve for y. Since we substituted 1 in for the x value and we generated a y value of negative 2, we ended up with 1, negative 2 as our starting point. So you can see going over 1, down 2, here is the starting point. We used an open circle. Open circle because it's saying that it's not equal to. So it's starting on that value but not including it. We also know that with linear functions, it's going to have a y-intercept of negative 6. That y-intercept of negative 6 will give us the second point on that line, which is why it started at 1, negative 2 and crossed through at 0, negative 6. On the other line, you can see that we still substituted y or x for 1, and then we started simplifying for y, and getting negative 5 plus 10, y equals 5. So we substituted x value of 1, generated a y value of 5, giving us a starting point of 1, 5. So you can see we go over 1, up 5. There's the starting point of the second line. We know that the parameters on that, we're saying all x values greater than or equal. So that's going to be a closed circle. That's why that circle's colored in. We also know with linear equations, we have a y-intercept, y equals mx plus b. That's going to be at positive 10. So, well, oh geez. But that's not going to be an x value that is greater than or equal to 1, because it would end up somewhere over here. So that's not a valid point. Well, what are we supposed to do? This is where we use our knowledge of linear equations. We start talking about slope. So we know that the slope is negative 5 over 1. That's why I went down 5 over 1 for the next point. And all we need for a linear equation is, or a linear inequality, is 2 points to graph a line. And this is us using all of our knowledge of linear equations and inequalities to be able to map this out. Let's take a look at some other examples. So you can see here that we have if x is less than or equal to 0. I'm just going to go ahead and write both of these formulas, or both of these equations, as y equals negative 7 and y equals 3x minus 5. We can see the parameters here. We have x is going to be less than or equal to 0, which means that we're starting with 0. And we also have x is greater than 0. So this is going to be, I'm just going to put it next to it, a colored or filled in circle and an open circle. So what we're doing right now is we're filling in if we had this value of 7. So 7 has to be greater than or equal to 0, negative 7. Because that's telling us y equals negative 7. So here that is down there. Use a different color. It is down there. Y equals negative 7. Negative 7 is less than or equal to 0, so it matches the parameters. Check. I used a colored in circle because it was a colored in circle. It's or equal to. Now what this did was it gave us an x value of 0 because we started at 0. That's why we have it at 0, negative 7. And our y was already equal to negative 7 whenever we wrote the formula or the equation. So that's awesome. That's very good. And we know that it's going to be all values that are all x values that are less than 0. So that's going to be everything going this direction And we know that y is always going to equal 7, because that's what it says, y equals 7. Anytime we have y equals -7, we have a horizontal line. If it were x equals -7, then we'd have a vertical line. We can use the same type of strategy to go about solving for the piecewise defined function 3x minus 5 with the parameters of x being greater than 0. Use a different color. So we know that x is greater than 0, so what we're going to do is we're going to start with an x value of 0 and everything greater than that. This is also going to give us an open circle saying we're not including 0, but we know it's going to be all x values greater than 0. So 3 times 0 minus 5. 3 times 0 minus 5 is 0 minus 5. We got y equals -5. So now that we have a nice y equals -5, we know that we substituted 0 for x and -5 for y. That's going to give us our starting point. We know that's going to be an open circle at -5. Right there. We know that it's going to already have a y-intercept of -5, and that's exactly where we started. Now we can use the slope, and we can go up 3 over 1. So up 1, 2, 3 over 1. Up 1, 2, 3 over 1. This is going to generate the points for our line by simply using the linear functions, substituting or using the slope. So we know that's going to be crossing through there. If I missed the points, there we go. Okay. That is one example. Let's do it again. Ooh. It looks complicated. So y equals x minus 5 and y equals 2x minus 7. What we're going to do is say that, well, we have to substitute something in that's going to be an x value. We know that by rewriting this, we have x is greater than -2, and x is going to be less than or equal to +2. So our first one that we're going to do is say, well, we know that x has to be greater than -2. So we're going to go ahead and start with a -2. That's going to be -2 minus 5, y equals -7. So whenever we're using that value of starting at -2, this is what we generate, y equals -7. That gives us an x value of -2, -7. There are our coordinates to where we're starting. We know that that doesn't have a line under it, so it's not going to be equal to. That's going to be an open circle. So -2, -7, open circle. Now we need to solve for the other set of parameters for this single linear equation. So I'm going to rewrite it again. Y equals x minus 5. And this time we're starting with a +2. We know that all the x values are going to be less than or equal to +2. So this is an open circle. This will be a closed circle. Now we're going to do 2 minus 5 and get y equals -3. That will give us coordinates of 2, -3. We know that's going to be a closed circle on 2, -3. So that creates our 2 points. And this is where we're talking about all viable solutions along this line. This is a valid point. We could use the coordinates of 2, -3 for possible solutions to this set of piecewise defined functions. This would not be included because it's an open circle. It is giving us a starting point, but it's saying not equal to this point. Also, all x and y values on this line are valid for that function as well, as defined by the restraints or limits designated on the x values, or our domain. So let's go ahead and do the next one. Take a look at it. So we're going to rewrite it, say y equals 2x minus 7. And you can see this looks complicated again, but all we got to do is rewrite it, and that'll give us our minimum and our maximum, like where are we starting and where are we ending. So x is going to be greater than 2, and x is less than 6. These are both open circles. I'm just going to put little open circles next to them. Y equals 2x minus 7. So we know that for this top one, we're starting with an x value of 2. It's going to be an open circle, but we're starting at 2. And all the values greater than that are going to be valid. So we're going to go 2 times 2 minus 7. That's 4 minus 7. Y equals negative 3. That will give you 2, negative 3. So what we're doing is we're going to go over to 2, negative 3, over 2, negative 3. Oh, wow, it's already a point, but I'm going to put an open circle around it. So that means on this other function, it's still on a point that was included as a possible value for the first function, but now we're saying it's starting at the second function, but not included. Cool. So now we're going to go to the bottom part. We're going to say we're starting at 6. All x values less than 6. But 6 is going to be our starting point, and then everything less than that will be valid. So 2 times 6 minus 7 is 12 minus 7. And that will give you y equals 5. So now we have coordinates of, let's see, 6, 5. So we're going over to 6, 5, and you can see that there's the other part of the second function. Now, if this were to keep going, we could see that it would cross through at negative 7, which coincides with the y-intercept. We can also validate this and follow the slope of the 2 points and see if it does line up. So I'm going to use yellow. We have a slope of 2, so up 2 over 1, up 2 over 1. If I'd have drawn the line straight, this would be on it. And then up 2 over 1, so if we're looking at a straight line, that'd have been right. Cool.